is pretty neat. This is an evolving capability, 20-second video, but I don't think it's too far from where we're going. It's the most basic level. We already have, we're going to have a lot of this data, so we're going to have the points, we're going to have the lines. I think the only thing different about this that we don't always collect is some of the elevation or depth values. So if we knew how far things were underground, I think we could build a model out like this pretty quick. So I don't think we're that far away from seeing something like this. So I don't know if any of your kids or you guys have those VR headsets that you can play video games with it, but I imagine that could be something that you'd be putting on your head and walking around the streets and looking a little bit goofy, but you'd be able to see something like this, which I think would be pretty neat to have. So you're looking at just the points and lines from the GIS. Those are the symbols they're using. But putting those elevation data or the depths of those lines in, we'll be able to see where things are underground. So similar to how you would just click on a point on a map and have a pop-up come up, apparently you can do that with your finger on here. And that would be to see the pictures of them, to pull up any kind of information. It's hard to tell what was on that pop-up there, but any kind of relevant information, the who, what, where, why, when of that manhole. I guess with the flick of your finger, you'd be able to see that. So maybe that's where we're going. I haven't seen this too mainstream yet, but it seems like a New Jersey water utility has started this stuff. All right, so how to get started with GIS. We're going to look at two main components of it. Options for GPS, and that's going to help you with your data collection, and then GIS software options. We're going to talk about a couple of them, but then we're also going to demo some from Esri. And it's called ArcGIS Online, is where these applications come from. And then we're going to talk about collecting asset inventory. So really the first step in GIS, the first thing you're going to do if you have some of this equipment, you have the software, is to get that full complete inventory, to know what you have in the system. That's really the baseline. That's the bottom of the pyramid when you're talking about GIS, is having that full, accurate, complete inventory. So let's start up poll number 3. Does anyone have their own GPS equipment? So something beyond a smartphone, any kind of GPS receiver, like a Trimble, an EOS Arrow. There's some, or an EOS is the name of the company, or a Bad Elf GPS receiver. Something beyond just a smartphone, which I'm sure you could argue is kind of its own GPS equipment too.
Okay, we got almost 80% voted. Participate if you can. I know some people are having a couple of issues. We'll give you a few more seconds. Okay. 86%. Fantastic. 89%. Alrighty. Let's share results. So 32% said yes, I do have my own GPS equipment, and 68, or our utility does, and 68% said no.
That's pretty good. That's almost in line with who uses GIS. Maybe it's the same folks. I'd hope if you have your own GPS receiver that you're using GIS, but if not, maybe we can help you get it going again or motivate you to get started collecting some data. So where do you start? There's a lot to pick from, both in terms of accuracy and pricing. Generally, the more you pay, the more accurate that GPS receiver would be. There are some options. It really depends on what you're looking for, what your needs are, and yeah, knowing what your budget is as well. So on this slide, anything from a $13,000 receiver that will get you down to centimeter level. That EOS Arrow, the 100, that's what we use here at RCAP. That normally gets us sub-foot, or what's kind of neat and convenient and kind of newer to the marketplace is Bad Elf, and they have some cheaper options. I'm not sure. I think there's some even cheaper than that $700 option, but that one would get you sub-foot as well. So That seems like you'd maybe get the most bang for your buck if you're looking to get a GPS receiver on a budget. And what's really nice about all these, it's a BYOD market now, so it's bring your own device. So you can use any of these three devices here on the screen, and they will work with your smartphone, your smart tablet, anything like that, any kind of device, generally an Android or an iOS device. And there are other GPS receivers that are handheld units. We have some of those at RCAP too, some older Trimbles called like a Geo7X. That's kind of an all-in-one unit. I think the overall GPS market has shifted to bring your own device, so people would rather work with their smartphones and smart devices rather than that handheld unit. And what's nice about using your something like your smartphone to manage your GIS and your data collection is that once you collect your point and hit submit, that data is automatically moved to the cloud. It's submitted there, it's permanently there, and that anyone that would have access to those maps or those apps would be able to see those updates in real time. So any kind of changes you're making in the field, your manager back at the office would be able to see exactly what you're doing and tell that you know, collected that point there or made the changes to it or did the inspection at that point or added your photo. And as soon as you hit submit, that change is there permanently. Sometimes with some of the older handheld units, there are some processes for correcting the data or pulling that data off, then you have to manually upload it to GIS. So this is really the trend and probably best solution if you're looking to get your own GPS device. Again, you can just use your phone as a GPS device. The accuracy is not going to be sub-foot, it's not going to be centimeter. It's going to say normally around default about a 15-foot accuracy. It's not quite as good. Maybe you could get away with it for some of your operations, but you know, for a little bit of money, we can get better accuracy on our data. So where do you start? Assuming we just purchased our own GPS receiver, um, it's good to look at what kind of records you have now. Do you have any spreadsheets with information about your data? Do you have a meter list? Do you have addresses? Do you have account numbers on curb stops? Do we have any old records that would help us with our initial location if we're not so sure about where some of our assets are? If we suspect that some of them may have been paved over or in the middle of the woods. And it helps us, and it would probably help you out if before you go out collecting with the GPS receiver to go paint things, to mark them up. That's easier for to find them later down the road, especially if they had to get buried again. But it helps to paint just to help you know, new folks as well tell where things are too. And down here, if you want to really go above and beyond, before collecting manholes, you could open those up. We could take pictures of the insides of them. And then like it shows here, you could paint some of the pertinent information, line sizes and material and the flow direction right on that manhole lid. You paint something like that, take the picture, then we would make sure that it would be accurately conveyed in our GIS system. Otherwise, you don't maybe need to do any of this stuff. You could just really go out and start collecting. A lot of these systems, if their data is so messy, it would take forever to go through and figure out what they have. And you're a smaller system, sometimes it's just good. Just get started. Start walking out on the street and seeing what you have, and start doing that full data inventory. And then as far as software, we use Esri's ArcGIS. That's really the industry standard. They kind of run the GIS world. There are some smaller companies that do this. A lot of them run on Esri technology. There's not really not a different alternative. It's not like buying a car where you have different options that are pretty equal. Esri kind of runs the show here, which mostly is good. I'm sure there could be some cons about it, but what's nice about it is that, you know, they're in every industry. You know, every type of business uses them, but they do have applications and data models specifically for water and wastewater utilities. And then compared to some other companies and smaller companies that may do this, or some of the open source stuff we'll talk about, they actually have a really good support team, professional services. They're continually updating and upgrading any of their solutions or applications. Anything that we can use with them in the field can be used with or without internet. Maybe the negative would be that is the cost, and it can, depending on what you're trying to do with it, depending on your licenses need, it can add up. But at the most basic level, there's a lot you can do with their basic licenses for really less than $1,000 a year. Then the other competing, if you could say that, choice would be something that would be an open source program. There's ones called QGIS, PostGIS, I think one called Grass, Mapbox. These are going to be a little bit trickier. They're going to be buggier. They're going to be harder to set up. They're not going to have all the applications. But if, I don't know, if you're a little bit crazy in the head and you want to mess with this stuff, maybe you could get a workable system. But I've always thought personally, I'd rather pay $700 a year out of pocket than try to mess with any of these open source programs. Alternatively, there's a program called Diamond Maps. I don't have a lot of experience with it, but I know a lot of rural water systems use it. It's workable, it's usable, it's not going to have all the Esri applications and everything Adam's going to show you today. It's not going to be able to do that kind of stuff, but at the most basic level, if you just want an inventory, you just want an accurate map, that would probably work fine. And I think that's something like $25 a month. So we're always happy to talk about the different options here and what you could expect to pay. But generally speaking, the most basic license that I would recommend to smaller systems costs $700 a year, and that gives you a lot of different access to pretty much all of Esri's applications, and there's a lot you can do with that. So some of these applications, like we talked about, what's nice about using Esri and these field apps and the GPS devices that are connecting to our smart devices, it all relates back to the same data source, which sits in the cloud. So whether you're using an application in the field like Field Maps or any of these desktop applications, dashboards, Survey 123, everything that's part of ArcGIS Online, it's all talking to that same data source. So changes that you make anywhere through any of these applications all talk to each other, so they all get updated at the same time. So you don't have to mess with different data sources. There's really one master data set that everyone would be working with, no matter if you have one person or 10 people in the field, it's all talking to the same place. So these are the two main Esri applications that we're going to get into today. Field maps, that's what we use for the GPS data collection. So you can record the location of your assets, you can collect the who, what, where, why, when of them, you can take your photos, you can view those points, you can edit them, you can do measurements, which I find nice sometimes. Sometimes we know the distances between two manholes, so you can do measurements between 2 points. You can also draw on there any kind of water or wastewater lines. So that's, again, going to be used to manage your system, to collect those points, use it in the field to see where they're at, make some basic changes to them, take the photos. And then we're going to get into Survey 123. So this is more of a smart survey, form-centric solution. So this is used more for inspection. So if you're on a hydrant or a manhole inspection, a hydrant flushing, if there's a water break, anything that you would have a form with in the field. And that could be something that you're doing at different intervals, so weekly, monthly, yearly, any kind of form that you would fill out. You could use Survey 123, and all this data is going to still relate back to whatever asset you're using in the field. So that manhole could have an attached form, the hydrant could have an attached form, and they could have many of them. So what's nice is if you're tracking all the hydrant flushings that you do twice a year for the next 10 years, all those different forms that you've used for that flushing would all be attached to that original hydrant point. So again, this is your one-stop shop for all your stuff. And it's really anything that you're doing with paper is what we could convert over to digital and use in your GIS. All right, so ArcGIS Online, this is really the complete cloud-based solution. The link to it is arcgis.com. And really all these different apps that we're talking about, and maybe there's at least a dozen of them. We're not going to get into them all today, but we're going to talk about the field maps, Survey 123. We're going to talk about dashboards. Those are all kind of part of the ArcGIS Online uh, cloud-based solution. And with that ArcGIS Online, there's map viewers that you can use to really do the mapping work online. That Adam's going to show some of that. But then the dashboards are really neat too. So this is kind of a visual representation of your data that you can do a lot with. So monitoring any kind of operations, tracking them. It reports, remember, everything is stored in that one data set, so we can pull all this stuff in real time. So it's ways that you can view your data with bar graphs, pie charts, just visual numbers that would get updated as things are happening in real time. So great for management, great for operators that are tracking projects, tracking that hydrant flushing, how many of these are done, how many current water breaks are there in the system, or how much water loss is going on this year. These dashboards are really neat. I think we got some cool examples that Adam's going to show a little bit later. All right, so let's recap everything so far. So what do you absolutely need to use GIS? We need the software. So we need that GIS license. We need some kind of hardware. It helps to have a desktop computer, a laptop, and then ideally a mobile device. Now we need a little bit of knowledge on how to use them. What additionally is recommended to make your stuff a little bit better? GPS unit. Just to make your data a little bit more accurate when collecting it. So if you're spending all that time in the field collecting your data points, it's better to have that sub-foot, sub-meter accuracy rather than the 15-foot accuracy of just your phone. And then if you're a field worker, what two Esri applications on the mobile device could you use for collecting data? Like we just said, field maps and Survey 123. They're probably the most common two for water and wastewater utilities. And then Adam, are you taking over from here?
All right. Sounds good. Should we go and deploy a break now or hold off a little bit?
We could go either way. We haven't been going quite an hour, so why don't you keep going for a little bit, Adam?
Okay, that works.
We'll
All
look
right.
at about 10:30 maybe.
All right. I will take over and share my screen. Sorry, it's taking me a minute here. You made me a presenter, right? And it's oh, there it goes. Okay, it's registered. All right. Let me switch this. All right. Sorry about that. Just switch screens on me. Oh, current slide. All right, I'm just gonna reshare. There we go. Okay. All right, so now that Seth kind of got the basics laid out, we'll actually go into both water and wastewater assets, starting with the water assets. Um, Hydrants and gate valves are going to be the major assets that we GPS, mostly because of emergency response. Gate valves and curb stop valves, as you all know, are very difficult to find at times, especially seasonal. New York, you get plenty of snow, fall leaf cover, vegetation overgrowth. So all of that can be really useful to have a GPS point. And also, if you're looking in the dark, you get called in the middle of the night, that just makes it that much harder to find those valves. And the hydrants, it's good to have that GPS data because we can share this with your fire department and other emergency response management teams. So let's go in. And then the major assets that could be picked up on aerial imagery, such as pump stations, treatment plant, your water source, you could go ahead and start pointing those before we actually get out there in the field GPSing, so we could work with you remotely or on site to go ahead and start getting the information from those. But of course, if we do pump stations, we'll still want to go in person and take photos of the different pumps and really gather that data set. So again, starting with valves, so you have your main gate valves and then your curb stop valves. Today we'll be showing some exercise forms with Survey 123, so you can track your operation maintenance activity. And then I'll show that the symbology will be different based on what kind of gate valve you have. And of course there are butterfly and other valve types. In my experience, I've done this for about 3 years now, mostly in Kentucky and now Maine, New Hampshire, and coming to Pennsylvania and New York now. They're getting all over, but gate valves are the 90%, if not more, 99% really overtaken. But they do a lot of different functions. I'm sorry? All right. So if you have, a bunch of gate valves right next to each other, if you guys can paint out in your head a situation, I've almost seen every system have this where there's, say 5 gate valves stacked on top of each other, knowing which gate valve goes to the hydrant, which one might be air release. Most of them are going to be end lines or tapping valves. So and hydrant valves, of course. So just to deploy this next poll, what percentage of your all water valves do you currently exercise per year? And if you want to put in the chat, do you guys exercise while you flush, twice a year, once a year? How's that percentage get broken up? Do you do it all in one, big takedown? If you want to put any responses in the chat, I know it's about flushing exercising season. We got about half the votes in. We'll just take a few more moments. Got about 70% of people. All right.
D9, anybody else want to jump on there? Okay. So you've got 41% exercise 0 to 25%. So 9% said not applicable. A couple are in the range of 26 to 50 and 51 to 3/4, collectively 14%. And most people are exercising between 76 and 100% of their valves per year.
It's good information. Getting some feedback. Can maybe
Yeah, if you're not, sorry.
And then okay, so we'll continue. Yeah, so since a lot of you all are valve exercising, this will be very useful to add to your GIS or create a GIS system to record this operation. So, of course, exercising your valves, you're going to extend the life of that valve. I know a lot of systems, once they go so many years, they're very afraid of actually that person. I think we did that.
Hey, Seth, can you globally mute? the attendees?
Yep, I will.
Thanks.
Okay. And so, ensuring that the open close position, sometimes you might exercise, leave that up. It's, the last valve that you exercise. Forgot to put in the correct position. This is a good way to check that. Critical valves, knowing where your critical valves are is super important. Highlighting those on the map, we can symbolize that differently, especially if you have a few that you really need to check up on. I know in Kentucky we got a lot of flooding, so having those critical valves mapped out really helped the operators go to those sections to see, which parts that we have to shut off, and digitally just recording that operation activity. Okay, so having the GIS system really helps you analyze where you need additional gate valves. You can even have this map up during, if you are in the board meetings, or tell your manager to kind of show to demonstrate, hey, look how many of these customers that are affected because of this water break because we didn't have a functioning valve in the right spot, or it was paved over by the road construction crew or something else. I see that left and right. GPS a lot of gate valves, and there's a lot of scenarios where it's either not accessible or not functional. So the GIS is going to help mark these, and we'll show that. And I wanted to just show this quick video too. I'll just skim through it, but exercising machines, if anyone can put in the comments if anyone has their own trailer, is doing this, or knows someone, a consultant that comes by to help exercise those really stubborn valves. This is a really good way to prepare with GIS, highlight all those valves that you really need them to mark, and then you can actually go along. And this representative here, he actually uses GIS when he goes into each system. So if they already have the data, that's going to save that system a lot more costs and managing and finding those valves, marking, etc. So just having that, I think at the end, yeah, he's kind of plotting on his data logger there. But just know too that you can do on your phone, iPad, that's more the norm, but there are still the GPS data loggers. We even have a couple still. So let's get to some interaction, some demonstration. I will first show, this is going to be the simplest form example for water, a valve exercising form. So let me just start by going to the map. I'll drag it over here. So this is a system we just worked with up in Maine, and helping both their water and wastewater. So I thought it'd be a good way to demonstrate some real data examples. Did ask them, both of them, make sure. But anyway, so if we find a valve, you can see like our gate valves are marked with a red outline that goes to the hydrant. And you're going to have a bunch of side options. This is actually what you would have access to, this online website that has the map, and then you can also get the app on your phone and all of that. This kind of lays out the, here we go, the symbology, which that looks a little funky in the legend for some reason, but as long as on the map it looks good, that's all what matters. We actually do have the fire flow, which we'll get into that. But as far as the gate valves, if we were to just find a gate valve, kind of want to go start to finish, let's say, way up here outside their system. So we can just hit the edit pencil. It'll give us all of our options. Gate valves is the first option because that's what we're GPSing a lot of. And so you can reorganize this however you want. This was bundled like these black emojis together as other, but they kind of split up when you actually GPS. So let's just say we're doing an inline. It was a brand new water line that's getting installed. We can add that valve in the field. It'll get our current location. We can put the IDs later, really the street address. That's good to mark while you're out there. Something cool we can do on our end is reverse geocoding, meaning if we have a point on that address, we can use Google and ArcGIS to get that address. So I've actually done that a lot of the times if there's data without addresses. And then we can put the location, what kind of surface it's on, the purpose. Again, we already chose that. And just choosing a size, putting kind of your general, if anyone in the chat, if you want to put, does anyone have multiple directions valves? I know it's kind of flip-flop depending on your system layout. But that can be really useful when you have multiple valves turning different directions. I don't know why that's not too common, but they still do exist, different directions. So anyways, this is all information that will tie in. We'll create the point. There are a few like required fields that they want you to, or not required, but that they'll highlight. It'll still let you GPS the point. And then now we have a brand new inline gate valve on here. So if we go back in the viewing mode, we can see it there. I didn't fill out any really information except some of the defaults on there. But we have this little custom exercise valve button that I configured. When we click that, let me pull this back up here. This form will pop up. It'll have the exercise date as today. Usually this defaults in the field. I am using the computer web version. So it'll get your current time. You can put the condition, make sure it is that direction. This system did have multiple of both, so they wanted to make sure. And then all this information can pop over from the map into the form as well. So if you already have this information filled out, it'll already fill out for you. We can add a bunch of information to this. This is a very basic form version. They just want the number of turns, any damage comments, and if it was exercise. The cool thing about this is being a related table, we can have multiple records inside these tables. So we have an exercising maintenance form, and that's where that survey actually sends this data into a form that we can have multiple records of. This is a brand new system we've been working with, so I just got this functionality added, so we're going to be using that with their records. I know they've already done some this year, and we've started with the fire flow, and we'll get into that in a little bit. Does anyone have questions, comments with the valve exercising so far? Go and scroll down here. So we're going to go to our next poll. Let me just get this back up. Okay, so the percentage of hydrants in your system do you flush per year? Again, this could be twice a year, just add that percentage up together. Does anyone have any flush hydrants? I know, like Kentucky, it was very common to have flush hydrants, especially in the very rural systems. You have a lot of dead ends. They call them haulers. You guys have any flush hydrants too? I've seen a lot more just fire-rated hydrants in the Northeast so far, which is good. But you can't always ideally have, enough pressure and flow. Okay, so we're getting almost about 60%
Yeah,
if
let's
you,
get those votes in. We have a
make
not
sure.
applicable choice, I noticed. That's handy.
Yeah, if you don't have hydrants, hit that not applicable. Just checking
Okay,
out.
maybe people took a break early. So you want me to end it? No?
Yeah, go ahead and end it. We
What?
got,
Oops. Ooh, it disappeared.
oh, that's okay. It said I saw the majority. I think we might be able to pull. I can view it here.
Oh, I am so sorry. I
It's okay. Utility
accidentally
image. Oh, here it is. Here, I'll share it again. Okay, so here's the results. Can everyone see that now? Or we have 76 to 100. Half of the people put 76 to 100%, with 0 to 25% having a quarter of the people, and then 20% non-applicable, 5% for the other two options. So yeah, wow, pretty big split up. I have seen a lot of more of like the 25-30%. So I think whatever few of you have put that, being honest there, so that's good. And if you're truly 76 to 100%, good job. That's a really good number to be at. So I'll stop
yeah.
sharing that. And okay, so there's a little more to hydrant flushing than just, opening it up and flushing. First, you have to locate all the hydrants, really brainstorm this procedure, and having, unidirectional sections, if not throughout your whole system, um, using pressure data and identifying in service, out of service, so you know which hydrants won't be able to be flushed or used in a unidirectional setup, and just accounting for your water loss and adding all of that together, ensuring that water flow for an emergency. Um, there are different pressure terms that you'll hear. The pitot pressure is the most common. That is when you're just straight up flushing, and say even a conventional flush, you're just getting that GPM, and the static pressure is going to be before you even open the hydrant. It's just going to be that sitting still pressure rating. And the residual will be when this is for a unidirectional setup, so a second hydrant would be used, and you would get that residual pressure while the flow is going. So, and I'll kind of demonstrate this better in a future slide, but reasons for flushing, most of you all probably already know if you've been doing this for a while. Routinely cleaning is the main thing, or if you have a water break or a localized problem, customers like, hey, but also to find water leaks, so don't neglect that. That's a good way to, and even leaky hydrants, check those when you're flushing. So conventional is going to be better than nothing, but unidirectional flushing is going to be better because you're just going to get higher velocities, and you're going to be able to flush more sediment out. So it's just utilizing the design of your system. Some systems don't have the best design to do that, but if you can find spots in your system for unidirectional, don't just think of it as a binary, like you're either doing it completely or you're not. There's always, improvement. I will say though, if you do, unidirectional flushing incorrectly, it can really keep all that sediment, knocked around in different spots. So it is important to make sure you have the pressure ratings to actually do so. And this is a list that you would want if you're flushing, ideal list like all of this. I know especially small systems here are not going to have all this equipment. You're going to be lucky to have, this static cap with the gauge. Most systems I come across just have a, pitot gauge there, but a lot more have started using the static caps as well. So when we first go to a hydrant, and we'll walk through this on the map too, you're going to get your GPS, the size of the barrel, and the hose nozzles are typically always 2.5 inch, but if you have anyone have any like 1800s hydrants, I just saw a few in Maine, just like 4 of them, but I was just shocked by, how many hose nozzles. There's like 4 of them, and they're different sizes. And so, I will say depth to nut, that's super important, especially for the northern states. I've noticed the difference going from Kentucky to the Northeast of how important it is to have all this information that's underground, because you guys are really excavating deep. And let's go through just quickly. GIS is going to be able to calculate all of these for us, but I do just want to run down what we're talking about. So if we're calculating water loss, your first step is you have to determine what the rate of a hydrant discharge is going to be, preferably in GPM. So that's your constant, that'll never change. And then you have your coefficient, which honestly most everyone just keeps 0.90. We'll go into that. That's just kind of feeling the inside of the hydrant nozzle there. And then the outlet size. So again, 0.9. I've talked to people that test hydrant, really do that for a living, just work with fire department, water utility hydrant solely, and 0.9 is very common to have a smooth and rounded outlet. But there are some outliers. So let's just do the equation real quick. So you would pretty much, the only thing that's really going to change in this is that pressure. Everything else is going to be mostly the same in pretty much every case. So it's not too bad of an equation once you realize, okay, I'm just changing that in the PSI there. And that would be your pitot pressure. So pitot, let's go in. Now that I've been talking about gauges, kind of curious, what is the gauge that you guys have in your system? If we could deploy this poll. Do you have a static gauge? Do you have a pitot? Neither. Is it not even applicable? And if you're a very small system, it's not too surprising not to have these, but a few $100s can go a long way if you can swing that. So okay, we're getting a little more responses. There we go. Okay, so we have 26%, well, actually leading, not applicable, so about 40% of you all. So I'll try to run through some of this hydrant stuff a little quicker. Static cap, 26% only, and then 21% have both the pitot and static, so that's good. I am surprised that some of you all have just the static and not the pitot. I've kind of seen the opposite. So if you guys want to share your reasonings, or let me see. So we'll go through, that's just kind of a recap. I'm going to skip through this. Well, okay. So the next step is your hydrant flow rate capacity. And again, we're going to do this all in the GIS. It's just a quick background. Just do know this isn't recognized by the AWWA, but there is kind of a point in flushing one versus two hydrants if you're trying to do diagnosis in the hydrant issue or the main capacity. So if you're just doing that conventional flush, then you're solely targeting that hydrant and the components there connected. Where if you're doing the two or more hydrants, then um, of course it's recognized. AWWA likes the unidirectional flushing, but it's kind of verifying different operations. So this is kind of on the back end, like good notes to keep um, in mind. So, and this was hosemonster.com. They're a pretty good website, and I've talked to the website owner, business owner there. Pretty knowledgeable person if you're ever looking to find some additional fire flow hydrant info. Um, so for the unidirectional flushing, you're going to want to know where the flow hydrants are, the residual, and this is where the GIS is really going to help out, as you're going to see in a second, keeping you on the edge of your seat, teasing you, but, X back button. So if we determine the fire flow, we can also color code it. How many people in here color code your hydrants? You can like use that raise your hand reaction. Uh, this is a really good way to communicate with the fire department and just with each other yourselves as a utility. And maybe eventually the public if they realize what these colors stand for. Or if you're a system and you color them the color of your local high school, I've seen that too. But it is becoming more common to color code it. If you have a engineer consultant, someone coming in, they can quickly identify what that pressure rated capacity is going to be, or the flow rate capacity. So again, this is kind of recapping, but this does show a better demonstration of here's the static um, hydrant and residual pressure that you'll get on one hydrant here, and then on the other hydrant with unidirectional flushing, you'd have your flow hydrant, and that's where you're getting your pitot gauge. And so to kind of walk through that process, you go to your residual, you're going to charge the hydrant. The flow hydrant's going to be the one that actually, flows the water out. And while that water is flowing in the flow hydrant, you're going to record the residual pressure now. So you're going to see that static pressure change just slightly to the residual pressure. And then you can determine an outlet nozzle, but we usually just do 0.9. Here's just another example to show that it can be different scenarios, that you can have multiple hydrants being charged with unidirectional flushing, from 4 directions, even that haven't really seen that with too many small systems. You're lucky to get a couple hydrants tapped in. Um, so yeah, and that is just another recap. So let's just go and get in this demonstration so we can get through the
So
high.
do you want to take a break? I realize time has got a way. I'm not exactly sure when the timing is best for your presentation. So
I think that'd be.
any time, let's say.
I think this would be a great time. Yeah. I'll go ahead and put the timer. Do you want to set that for a certain amount of time?
I would say 10 or 15 minutes. How are you doing on time relative to your,
I
are
think
you
pretty
pretty much
good.
on target?
Yeah,
Let's
I
take
think.
15 then.
Okay. Uh, I actually don't see that little timer option thing now. Do you guys have
Let
that
me
on
see.
your?
Hang on.
It might be because I'm in presenter mode.
Oh, that could be too. Yeah, let me get it.
I
Whoops.
think it's next
I
to the
got it.
one.
I'll put it on
Okay,
there.
Oh, I
thank
got
you.
it too. There we go.
Should be started.
See you in 15. Okay, countdown to getting started here. Adam, you're ready?
Yeah.
All right. Oh, to yours.
All right. Welcome back, everybody. Hope you had a good little break. So, oh, sorry, just hit the slide here. We'll get into the hydrant flushing now. This is a form I've worked on for a couple of years now. It's has a lot of different functionality that's ongoing support. So we'll start actually in the map again, just like the valve. Let me pull that back. Okay, so for a hydrant, we'll just go and create one to show you that breakdown. Um, not sure why the symbology did this. This is a new to my knowledge, so I'm gonna have to look at that. But anyways, based on if you already knew the pressure rating, you could go and select this. This community does have pressure ratings. Um, red we'll usually just put by default. Or if the community doesn't have pressure ratings, we won't even have this symbology. We'll just have something that's more like out of service and in service hydrants. Um, so let me go through, and this will show that there's some default values already preset. You can put by the road. That's usually what I'll set the default, but putting even the intersection, other location can be helpful. And then the custom notes. And then all the pressures you could go ahead and fill out. The survey is going to make it a little easier. And for anyone that doesn't know still the survey's purpose, it's really to replicate what you're seeing here on the map, just in a more digestible version, and that's able to do calculations and a lot more. The reason to use the survey 123 is to expand that functionality, and a lot of large utilities have actually used this crossover in applications. So, but anyways, there is a lot of information you can fill out. So with the hydrant, different parts. So we'll just jump into the survey, kind of breaks it down a lot easier. So when we actually in the sorry to jump back the map, you would click on the hydrant just like the valve exercising, hit this flush hydrant, and then it's going to pop up here, and it'll pass over this hydrant number, and I can show that, but just to go through the updating existing info, as you can see, it's a little easier to look at and click through if you wanted to update stuff. We can group it by the characteristics itself, condition assessment, and this is also how I plan to update a lot of the valve forms to kind of groupify everything. So the flushing and fire flow tests is what we would be doing, and you can set it to do conventional or unidirectional. Have a pitot gauge, static, or if you're not using any gauge, you can select that option. And I'll click both. And what I'm setting now to do is when we click the no gauge, it'll hide the pressure ratings because we're not taking them that day. But since we are today, we'll go ahead and put these in. So you have your static pressure. You can type in the pitot and then your residual. And again, the residual should be lower than the static by a little bit. If you put a higher residual, it'll actually break the flow calculation. I mean, you'll still get discharge rate because that's just based off of the pitot pressure. So another added thing, this is brand new, like as of a week ago, so I actually now that I'm looking at it, kind of reposition um, this above all three, but we can actually select the residual hydrant based on the flow hydrant's distance. So right now I just have a 10-mile buffer just to make sure it works, like we were putting in hydrant numbers. However, we're going to reconfigure that probably a half mile. You can also groupify it. So if you're doing unidirectional flushing, you can have different groups that'll limit, oh, this hydrant is from this group. So there's a lot of different ways you can go about that. But ultimately, you'll mark if it's flush, the number of minutes spent flushing. This will also auto-generate if we capture our flushing time. So if we put in the current time, let's just go ahead and do that. 11, well, we'll say it was 2 minutes ago. We'll do a really, really quick flush. And then scroll down. I'm trying to think where my end time date. I think I was still editing that. Sorry, this is like a newer version of my existing, more basic. But I wanted to kind of show it off because the cool thing with this again is we can see the hydrant numbers straight from here. And then you could click it and have that reference all in one swoop. And then you can hit the check mark who conducted the fire flow test or just the standard flush. And that pretty much sums it up. I know that's a lot of hydrant info. If you guys want to kind of talk more about that, feel free to email me. And then let's go back. The last water component we're going to talk about before we get to wastewater. Just give me 1 second here. Sorry, there's someone knocking on my door and they're very persistent. So, okay. So the last thing for the water side of things is locating the water mains and also recording the water breaks. So it kind of goes hand in hand. Just to cap over some background of locating the water mains to begin with, of course, having the GIS system, having those gate valves mapped out, you really get a lot easier to be able to tell where that main starts and ends. Of course, we all know with the different T's and formations with fittings and everything too, that sometimes it's not as obvious as you think. So using tracer wire for all PVC, I think that should just be a given. I know some systems don't put the tracer wire, but I think a lot more are now. Hopefully, I think the cost benefit definitely is worth it. And then you can also do some more in-depth analysis with conductive and inductive, but you will need the equipment to do so. And one thing I've come across just being in the field is word of mouth. Sometimes doesn't help you too much or might lead you the wrong direction, but there are a lot of residents that, they might have lived there a long time. Being younger myself, like I really had no idea from some of these old as-builds, and I'm not from the community, and we've really had some long-term residents really help us out. When it's like me and another say new operator, and then social media, I know that's like comes with a bite. A lot of people don't even want to have a Facebook page to have the complaints and ruin their reputation, but it is nice to get information right away, even if it's not in the most pleasant tone. I got that actually directly from a water utility I was helping with. So I'm not gonna mention who they were, but Pat was not having it that day. And then we can also pair up some data from SCADA that's more of a security breach. Like, so you can't integrate the two with any automation, but you can take that data. Say if you're in the treatment plant and there's a water break, you could take that diagram that shows your water amounts and save that, upload it to the map directly. So I've seen that done a couple of times just when you go back to a water break, and we'll get into that. But marking, of course, flags get moved all the time. I'm surprised how much customers complain about flags too. So it's another thing that when you're GPSing, what's nice, say if RCAP comes out, if you try to mark it all that week, let the community know, hey, it's just going to be this week, while we're GPSing, we'll pick up those flags. One heads up, there was a community that used stakes instead of flags. Does anyone else do that? I don't know. I wasn't actually there, but it did kind of slow down the process because they had to carry around a bunch of stakes when they're GPSing, about 1,000 curb stops that they marked. So that is something to keep in mind if you're putting like stakes instead of flags when you're GPSing. This is me down in southeast Kentucky, and they have tons of pipes that go creek crossings, and so just being able to mark exactly even the elevation of that pipe and everything is pretty cool. When you find some exposed pipe, go ahead and GPS those points. You will draw the lines more on the map, but just having as much GPS data, even if hey, I dug up this pipe like a week ago, I know it's right here, we'll just go ahead and tag that GPS point. And same with sewer, of course. And we're going to get to sewer and wastewater here shortly. So the smaller utilities, I wanted to point this out because, again, we work predominantly with systems under 2,000 connections. So it's really important that we stay on top of recording these water breaks because you have less finances to work with, especially areas declining populations. I know Kentucky, and I'm sure a lot of the rural parts of New York, a lot of people have gone to the cities and stuff, and that just really, wreaks havoc on the economy. And so you have to do more with what you have. And so I just kind of want to include this. It's a good study that you can look up with the Water Main Breaks 2018. So it's pretty new, but a lot of good information talking about the distance of your water line and number of customers per the mile. A lot of factors to consider, and the GIS mapping will be able to help you do more analysis. And this can even lead to grant funding opportunities and different things. So it's just really good data to have. Before I show you what the break log looks like with the GIS, just want to get another poll. How many does your utility system keep in inventory of your water breaks or sewer overflows? So there's a few different yes and no options. If you can put that, I will say, like, personally, in my experience, I do see more just work order books, and there's nothing wrong with that. I mean, especially just having that is better than nothing. And then we can even take that work order book and digitize it, so you have like a actual spatial point with that repair or water break or sewer overflow. So mapping isn't just GPSing our standstill assets. It's kind of becoming more dynamic and trying to understand what's going on. So we do have everyone voted in that. Well, about the percentage we've been getting, I should say.
Yeah, we'll give them a second more here. Vote if you're voting. All
Actually
right.
went up a little.
It did.
And about half of you guys put yes, intangible written record book. Yep. So that's pretty much what I see. And then also a third of you all about put in a limited digital system. So that's good. That's definitely, even if it's limited, we can take digital data a lot easier than paper data and put it into the GIS system. And even exploring options to kind of automate that process with certain work order systems, CMS. So thank you for those results. And we'll continue here. One last thing before the GIS demonstration, we'll kind of set each water break as a moderate, major, critical condition or severity. So we're going to go over just kind of the guidelines that we went by using the Highline Water District and Research Foundation and the Water Research Foundation. I meant thought they had pretty good description images. So your break type 1, that's just going to be your minor service line. Positive pressure was maintained, but there's probably not contamination. I've seen these GPSing just out and about, just kind of tighten them up and they're good to go half the time. Then you start getting into more of your breaks. So you don't necessarily have a loss of pressure in another part of the system. You might have obviously a little bit there at the pipe, but you're going to have a really limited possible contamination, as you could see in this image. And then break type 3, that's when stuff starts getting serious. You start seeing the pressure go, and the contamination is definitely going to be possible. So you want to get those samples. The critical break, that hydrant just has seen better days, I guess. Complete loss of service. I've only seen a couple of critical breaks in my time, and they're not fun to witness. So seriously, thank you all for being the operators, because it's not fun, especially in the middle of the night. I've seen driving by, like, it is cold and oh my goodness. So, but there's a lot of information we can record that gets lost, even by the next week or two, especially if you're having a lot of water breaks. I know infrastructure is really getting old now and the pipes are not holding up. So all of this data is more critical now in like the next 5 year, 10 years, like than ever, to start really capturing this, because I don't know how many breaks and leaks you guys deal with, but even if it's just like a dozen a year or something, that's still a lot depending on how small your system is. So let's go through this. The variables that you'll need is the duration, the size, the PSI, and then we can even put the cost to factor in the cost estimation that that break cost you. So we'll go through on the map. I did want to just show a different map. So this was one of the systems in Kentucky that I set up last year. I am now fully in the Northeast region, but where they had a year or so to actually capture some break date. I thought this would be a good demonstration. So just to kind of show out, I like to show a little bit like true spiderweb design of a water system here. I mean, there are like 1,200 customers, but you have miles and miles of pipe, creeks everywhere. I mean, so it's really good that they're a small rural system that, someone from state or someone, they really thought, oh, they're not going to do all this and stuff. But they had a new manager that he was operator for a long time at system, and he's like, yeah, I see the importance in this. And so I helped him go the next, 50 yards with it. And that's kind of what I'm trying to continue to do. So anyways, if we just click on any water line, and I wanted to show the satellite imagery. It
Hey, Adam,
is,
we're not seeing the map. We're just looking at the PowerPoint.
oh shoot, I'm so
There.
sorry. Okay. Okay. So yeah, sorry about that. That's embarrassing. Let me zoom out again so you guys can see. Um, you're getting the visual in your mind before. Um, hopefully you got the imagination going. See if it matches up now. um, so anyways, these marks here, the exclamation marks, are actual repairs, and most of them are going to be water breaks, but we actually started adding the sewer maintenance too. Um, there's a lot more dual license operators now, and that's a good thing in getting both the water and sewer on board. So let's just go through this. We could click any waterline. I'll show you some of like these exclamation points. Some of them have very little info and like say no photos, and then some of them have like multiple photos calculations. So it can really range. What I always tell systems is just um, even a little bit of photo, whatever it is, go ahead and record it. You can add to it later too. So this is a very minimal pop-up, just has their diameter constructed PVC. Pretty small system. They just want to kind of keep it simple, but we can always expand how these pop-ups look in any fashion. So if we, I'll just continue to discard that. So this kind of shows a pop-up method. It is going to get my current location, so I just kind of want to reiterate that. Like you can click on any water line, doesn't have to be the one that actually had the leak, because you might not even have it on the map. This is just a functionality to bring you from this map to the survey, and this would work in the same way on your phone, which is really nice. It's like a parallel um, example. So we can then click where exactly the point was. If I was standing on it right now, then I could put it there. Um, but since I'm not, I'm going to go to Garrison, and then I could plot plot it somewhere here. So, and we can also load in the map that was just showing inside this map. But it's going to really freeze up because it kind of loads a lot of data at once. So let's see, we're going to go today. We can put the kind of pipe that was broke, the main line or the service line, or say it was a different part. So then that'll actually change the options that we're seeing. And we can customize all this. This is kind of what I've customized and realized there's different terminology. Definitely open to feedback too. Always trying to um, get the best operator lingo, but also trying to get like a standardized phrases for some of these breaks and such. So if we do a main line and do a hole, it's going to ask for the diameter. Everything in red is what you have to enter for the calculations to work. Um, so if we do, say, a 1 inch, well, that's pretty small. We'll do like a 8 inch, and say our diameter hole of the hole is 1 inch. It'll calculate the area for us. We can put when we repaired it. So we'll put now. Let's say it happened yesterday or earlier today. So usually that'd be, we'll say, went on for a few hours, 8:30. And a lot of this is estimation. Again, it's just like working with more data. You could reference back, all the information that you know or you're estimating. And then when you put in your PSI, it'll actually calculate the water loss, and then inside gallons. Um, and what I referenced earlier, like one system wanted to have their cost per gallon because they actually go to the water boards to show some of this. So that's something I can add and take out. I take it out unless I know exactly the cost per gallon from the system because I don't want that to confuse anyone. But then you could add the cost of the repairs. And most importantly, photos of the water break. So again, if you just change these, that will change which kind of questions you're asking or what kind of parameters are needed. And then when you submit it, it'll go onto the map wherever you put or wherever you're standing, and it'll also go on this online website here. This is all secured, so I say website, but really you only have access and we only have access to it. You could make it public, but that's no really incentive to do that. So we can go to the data and kind of see it all in one form. We could also just turn off everything except the water breaks here. So there's kind of multiple ways, but here he's kind of put more description inside it. You scroll down. Now you guys are going to start laughing because how short, shallow these trench, how much they have to dig is not too much compared to New York. So, um, and I think it's probably, we could see like the date or August 29th, so at least. But anyways, yeah, this is a just great tool to have. Whether it's just little repairs, random photos you have on your phone, you can use any of that quote unquote legacy data and upload that. So if you guys kind of want to see more of this stuff too, again, just feel free to reach out to me and we can kind of customize this for your system. So let's go back into our glorious PowerPoint for a little bit. We'll go back in the GIS world. These are the calculations broken down. So again, this is all inside the form. And just to show you on the back end, actually don't have the water break one pulled up right this minute, but everything is in Excel format with these like calculations. So it looks very overwhelming. That's why we're kind of here to set that up. A lot of it gets automated in our like process, but there still are a lot of factors. But just do know like any kind of calculation, any kind of contingency is possible with these surveys. So during the break, we'll want to locate the appropriate valves to isolate so we can use field maps to do that. And then we'll use the survey to record the break. Then after, which I have it separated right now as like a sample survey, but I'm looking to just combine that with the water break form so you can just record the sample right then and there too in that same form. I don't know if you guys have feedback on that, if you would prefer having it in one form or two separate. The nice thing having it separate though is kind of having those sample points kind of stacked on their own layer, just like an asset. So kind of just went over that, spun the gun. But once you have all these breaks, Candace, was there another poll that I skipped or?
No, it doesn't come up till wastewater.
Okay.
But you're at 11:36.
Okay. So I'll start speeding through here now. This is the last part of the water, so we can actually get to some wastewater. So the water breaks you can categorize based on the year, break it down like into that street view. Here's an example of a bend here, and you can really see that they're able to make a case to do a replacement rather than just continuing to repair. And then you can take your samples. I'm going to go through, and then even your breaks can be mapped out like a grid formation if you wanted. This is a little more engineer analytical, but it is still pretty cool data to visualize. And then here's a screenshot of like the sampling that can be incorporated also with that. Water break, hydrant flushing, there's a lot of sampling that goes on if you're a water operator. So that's the chlorine residual. Just want to make sure we hit wastewater. Sorry, did not realize the time has snuck up on me. Let's go through. Want to just kind of highlight gravity, sewer mains today, and manholes. Um, this is an example before having GIS. A lot of wastewater systems, unfortunately, still are relying on the paper records. So we're really trying to push up our gears now and getting wastewater up to speed, just like water. And doing so, there's actually a lot more analysis, video attachments we can do. So much capabilities that gets overlooked. This even shows kind of the example of like drawing in those inlet outlet um, directions here, but you can view all that in images, videos, however you want to demonstrate it. Again, so do you have your manhole, septic tanks, grinder pumps is all points. Do you have stormwater? Is it combined? These are all questions that you want to kind of brainstorm, talk to us or whoever's helping you with GIS, just to make sure that we have a nice, good template to go off of. And then environmental data is super important for wastewater, like slope and soils. So the manholes, you can really break these down, that it seems like, oh, it's just a manhole, like if you stumble upon it as an everyday person, but really breaking down the components, and even if you are a wastewater operator, there is a lot more sub assets to consider that sometimes gets overlooked. So you have your risers that you can group together, the surface area with like the ring cover, that's kind of its own section as well, and then your bench table. So kind of just groupifying is like key for this. So just want to deploy another poll. If applicable, what percentage of your sewer manholes does your system inspect and provide maintenance for on average per year? All right, getting about half people. Let's just take a few more moments. Last call. Any stragglers? No.
Ooh,
Hey, that got a
77
couple,
is
right?
John. Look at that. All right.
Yeah, good job. Okay, there we go. I think we can end that. All right, so we have 40% of you guys put 0 to 25%. That's honestly what I would expect. I think it's good that the next one up, besides the non-applicable, is almost a fifth of you all put 26 to a half. So that's pretty good. And then just a handful does more than that. So that's very good. Yeah, I would definitely try to at least get to that 26-50% range, but really 10% is kind of like the minimum like threshold that systems should really go by. And especially, this is just like a metric, but based on your system age and the actual year that these manholes were installed and pipes. So you really have to consider a lot more than just going off a generalized metric like that. So going to the next level, we can use CCTV and really investigate underground and attach these videos to GIS, which is really helpful. And we'll kind of show video here in a second. But the GIS, the main thing first after GPSing them is just tracking, which ones were sealed, not sealed. You're going to be able to assess the vulnerability, susceptibility, more so of I&I issues. So this shows kind of example based on the different manhole numbers. You can see since these manhole numbers are in the thousands, it's a big system. So they're able to really analyze every manhole, but really breaking down each manhole's I&I susceptibility is really important with GIS. So we're going to get into that. Just want to go through a couple other examples other than CCTV because that's probably the most common for wastewater usage with GIS like integrating it. But drones, I know I've heard a few operators having drones, so that would be an awesome thing if you do have one, or if you could convince your utility to get you one and get licensed. You can do, I mean, even on the water side, you have the water tanks inspection, but the wastewater side, it's really cool because smoke tests, you can fly the drone behind, like residential smoke tests. It's like super useful to see where that smoke's coming from and capturing images of that and putting in a report. Our Ohio team in our RCAP is doing a lot of this, so hopefully we'll get a little more hands-on with it as well because it's super cool stuff with the drones. But to go back to the CCTV, this is video that um, more recent than a lot of the videos I'd come across early 2000s, late 90s, where it's like you can hardly make out what's going on, but video quality is gone. Oh, yeah, there you go. So, yep, that I forgot that I had the sound in there. So, um, I thought that was someone talking for a minute. I was like, what? Okay. But anyways, yeah, um, we can then record that into the dashboard. So see like which ones and overlay parcel property data. So I'll show that again, the property data boundaries. That's going to be really useful for a lot of different applications. Um, there's even a CCTV solution that's predefined by ArcGIS, and then we can like customize this solution. So let me I'll send like a link, or we can like send out something to that too, because there's a lot of good examples that might not be able to have time to show, but I do want to show some actual workflows on the GIS, so I'm gonna just kind of skim through a little of these PowerPoint slides. But the main point is asset IDing is super useful, like getting the upstream and downstream IDs from the manholes and connecting it with the sewer pipes. We can kind of automate that process on our end and make that asset management really strong to start off with that asset IDing if you have a GIS system. And then we'll show a little recording tracking like maintenance with the lateral. So to go over course, I'm sure most of you already know the lower and upper lateral, but kind of having both of these on repair points, just like the main water breaks, we can do the same thing just with any kind of repair. So really not restricting it just to our wastewater and water mains, but also doing the lateral and service lines. So again, just GPSing this point. I'm going to run through this so we can get some actual mapping in. This is an example of the survey with the upper lateral investigation. So this is going to be, more on the public side. And GIS really has been evolving to include the public side more, so we can just get really quick data from just a conversation, and then also being there on site doing the investigation. So the main key points for the system design is going to be like your slope and the condition of the wastewater assets. I said slope, but really it's an overall system design, not just the slope. Could have a lot of other factors at play. So like the soil, of course, and some utilities I see have a lot more rocks in their soil than others, or a lot bigger ones too. This is an example that we can streamline with GIS instead of doing, an engineering toolbox of looking at a graph. We can actually auto calculate this. So let me just pull up. This is actually our more robust software, ArcGIS Pro, that we have access to your map through, that we can do more analysis work. So there's like a few things that take a little more work to do on the online side, so it's kind of easier just to have us calculate it or create some automations that we could configure. So I want to go through an example here, and just to highlight that point, if we look on here, this is same exact map. The only difference is like the arrows were added on the online, and they have to be kind of redesigned. So if we scroll in, we can just hide the water for now, like completely just turn off this group. We could turn off infrastructure if we just didn't want to see the roads or the parcel boundaries. This is kind of all stuff I wanted to show before we go here, because I know I got about 5 minutes now. Doing the asset IDing again, so this is the sewer line. We're going from this manhole to the next, and just having that as kind of the title there, having the diameter, and then from there we can actually get our surface elevation from some online sources with the manholes. So like Maine, they had a 5 feet. I'd have to look in for New York what elevation data is available, but probably the same. Sometimes it's 2 feet or even 6 inches that we could get the surface elevation down to. That's the accuracy. And then we can, let me scroll up here. There's a lot of fields in here. So the surface elevation / rim would be 50 feet. And then if we go back into here, we can view this length. This automatically calculates, so that's going to be 300 feet. And then through the manholes, knowing the elevations of each manhole, we can get the slope calculated in here. So again, that's from to that manhole. We have our downstream elevation, our upstream elevation, and we have our slope that's just calculated from those two fields, the difference. And then we can calculate our velocity, and that's going to help us get that carrying capacity. So this is something like we would do on our end very easily. We can do all the manholes at once, say if you had all the invert depths for the manholes, then we could get the surface elevation for you and actually calculate this, and then you'd have it, there at your disposal. And what that calculation looks like, it's kind of my scattered notes here, but I'll copy and paste it. We have, which I have to show on the slide to really dissect this here because it just looks like a bunch of numbers. But zero point 0.5 is assuming a 50% filled water. This can range a lot, like, or you could change this mark. So um, that'll be kind of the last I want to reference. So this kind of makes sense. And I'm really skidding through this, but we can deploy. This is the last poll question, I believe, right?
Yes, it is.
Okay. So do you have experience utilizing your elevation data? This could be just looking at paper maps or using digital maps. Probably mostly have paper maps, if you even have those. So sometimes the paper maps don't have, your contour shaded reliefs. Most people just call it topographic maps, which can have contours, can have something else. Doesn't have to be, usually does. All right, we got most
Anybody
everybody.
else want to vote?
You
Oh, there's a
stragglers.
couple. Get those
There we
votes in.
go. I think
All
that's
right.
all right. So at least about half no, and then about half paper maps almost. And then a couple of you all using digital, so that's good. Um, let's just continue through. I know I need to leave like at least a few minutes for the exit.
Yeah, you're wrapping it up, winding it up
So,
here, and that gives them 5 for the test. So take a couple
but
minutes.
yeah, I'm just gonna go through these last few slides here. Um, Definitely, if you're part of the wastewater utilities, want to reach out, I can really show more of these tools, and we are actively trying to get more wastewater projects on board too. So, but the reporting can really be used for both. This is a clean, just easy example. Just having your miles of gravity main is really nice to have, and a quick consumable dashboard that all of this is going to come from the GIS. This is going to be something that's a little more intense, a bigger system. They got their house calls there, and but it just shows the capability is really left to your imagination. Just to revert back, this is another water example, but for the hydrants, like everything that we do, we can group them together, the ones that need maintenance, weren't able to flush, etc., water violation reports. Um, so hopefully after all this, here's the summary, evaluating. I'm going to just skip through that. If you could get our emails, though, any follow-up questions, feedback, would greatly appreciate it. Definitely going to restructure up this training a little bit. It's a lot to cover, so we might even have to break it up more.
Well, that was great. Yeah, I'd make it a little longer next time. So
Yeah,
especially to really
I
get into
should
that
have
wastewater
made
some
that break
more.
10 minutes, but I really
Well,
wanted
that was
everyone
great. It was great, Adam. You and Seth, thank you both so much. It was very informative and interesting, and I hope other people enjoyed it as much too. So I just wanted to remind you all that we're going to do the post test, which is another requirement of our grant and a requirement for if you're getting credits. But at the end of the test, or whenever you close out, you're going to automatically have our evaluation form pop up. And I got to thank so many people who are filling out these evaluations and telling us all kinds of things we need to hear and sometimes really love to hear. So it's great that you were able to join us today. And I'm sorry we don't really have time for questions, but as you can probably figure out, we're first initial of the first initial of our first name against our last name at rcapsolutions.org is how you reach all of us. So as long as you know our name, you can find out who we are. But with no further ado, I'm going to launch your test and see if we can get you out of here pretty close to on time here. Thanks again for coming, and thanks again to our presenters.